Hey kids, how you doing? I've been telling you for a while we're gonna start to tie all of this stuff together in our quadratic graphing unit, and that's what we're beginning now. So this is the lesson for Tuesday, May 5th. Remember, live lesson, of course, at 1:30, as always. Some of the stuff will be review in that we've talked about it here and there, but some of it will be brand new. Definitely want to be on top of your game here. Okay. So this equation, of course, is a quadratic equation because the highest power present of the x is 2. We've been talking about that for a long time. All quadratics graph out as a parabola, okay? We've talked about that too. Now that parabola can open upwards and create this U or V-shaped thing. It can also open downwards, be upside down, but it will not open sideways. That's a different kind of function. So it's only going to open up or down. All right. Now, the parts and pieces of a parabola. A parabola, and you've heard me mention this term before is critical points. A parabola has 4 critical points. Sometimes it might have fewer. All right, 4 critical points. Now, the one that you've heard me mention has been the vertex. The vertex, of course, is this thing right here. In this particular problem, that coordinate is, what's that, -1, -9. But the vertex is a critical point. That's where kind of everything changes. We'll talk more about that vertex here in just a second. A parabola also will have a y-intercept. That's another critical. Sorry, I gotta fix this here. Now the y-intercept in this particular problem is right there. And that would be what? 0, -8. Okay. Now the next thing is 3 and 4 are the solutions, also known as the x-intercepts. Now here, our solutions are right there and right there, okay? So here we actually have 4 critical points, but we've talked about how parabolas sometimes have no solution, so they don't have any solution. There might just be 2 critical points, just the y-intercept and the vertex. Sometimes they just have 1 solution, so it could have 3 critical points, but it won't have more than 4. Now let's go back and talk about this vertex again for a moment. Okay, so the vertex is where everything changes. When you have a vertex, you can draw a vertical line right down through that vertex, okay? And that line is called an axis of symmetry. All right? And what that means, I hope you should be familiar with the word symmetry. We're essentially talking about a mirror image. You could take the parabola and fold it over that axis of symmetry. If it was a piece of paper, make a crease along that axis of symmetry. And this side of the parabola, the left side, if I fold it over, would match up perfectly with the right side. So everything, notice how here the axis of symmetry would go right through -1. Notice how this solution here is 1, 2, 3 units away. And this solution here is 1, 2, 3 units away in the other direction. So there is symmetry about every parabola around that axis that goes down through the vertex, okay? Now, the axis of symmetry, when we talk about it, it's always going to be a vertical line. All vertical lines have an equation that begins with x equals. So in this particular problem, what is the x value of the vertex? Well, the x value of the vertex is -1, so the equation of that axis of symmetry is just x equals -1. Okay? That's it. Every axis of symmetry is going to have an equation of x equals some number, and it's always going to be the number that is the x coordinate of the vertex. Okay? Axis of symmetry is always going to go down through that vertex. So, four possible critical points: vertex, y-intercept, and the two solutions. You could have fewer. Now here we've already answered, find the y-intercept of the above equation. We already wrote down the y-intercept based on the graph. We just looked at it at the graph, okay? But remember, the equation said, I don't want to be green. I'm going to save green as my axis of symmetry. My equation said, I'm just rewriting it, x squared plus 2x minus 8. We know that all y-intercepts have an x-coordinate of 0. So if I plug 0 in here, that goes away. If I plug 0 in here, that goes away, and you're just left with the -8. So that's another easy way to determine the y-intercept if you didn't have the graph in front of you. If your equation's written in standard form, the y-intercept is simply this constant that's just hanging off the back, because all y-intercepts have an x value of 0, and it makes all the other stuff go away as long as you're in standard form. Now, find the x-intercepts of the above equation. Again, we already found the x-intercepts. Here, we knew that x was going to be -4 and x was going to be +2 based on the graph. But we don't always have the graph in front of us. So if we were to solve this, again, I'm just rewriting that equation. We're going to use all of our quadratic solving skills that we've learned now over the weeks. Remember, x-intercepts means that y is 0. So I'm going to change that, and then I'm going to think about, hey, this leading coefficient's 1. I'm thinking I could maybe factor this, and I could factor pairs of 8. That would be 4 and 2. Signs are different. And check this out. I get -4 and I get +2, which of course matches what I wrote earlier based on the graph. So you see, we have different ways of figuring this out from the graph or algebraically. Okay? All right. So now I'm going to throw another term at you. I've been referring to the solutions and the x-intercepts as the same thing. And they are the same thing. Okay, there's a third term called zeros. All three of these things mean the same thing. X-intercepts, solutions, zeros. All three mean the same thing. So they can be used interchangeably. Okay, I've been saying solutions most of the time and occasionally x-intercepts. I haven't really used the term zeros yet. But the reason why it's called zeros is, of course, the y value of all x-intercepts is 0. All right. So I'm going to show you here, it says find the zeros. So I'm going to show you, we can just do what we just did earlier. Zeros means x-intercepts, change the y to 0. This looks like it's easily factorable, and it is. 3 and 1, that would be plus, that would be minus. We would get solutions of -3 and 1. Okay, now I'm going to show you something else. This is definitely a lot harder to do remotely. And you know, a lot of times you're going to be given a table of values. Remember, there's an infinite number of coordinates that make up all of these parabolas. Okay, an infinite number, and we can usually the x's we just kind of you see here there's just a string of x's. Where do the y's come from? Well, we just take these x's and plug them in here to the equation. Now I'm going to show you this first one. If I plug in -3 squared, and that would be plus 2 times -3 minus 3, that's 9. That's -6. That's -3. Well, 9 minus 6 minus 3 would be 0. Okay, you can use your calculator to help you with that. That's fine. If I plugged in -2 here, you know, I'm just, remember, use parentheses because you're squaring the entire -2. So that would be 4 minus 4, because 2 times -2 is -4. 4 minus 4 is 0. 0 minus 3 is -3. So I can do this for every one. It's kind of you know, a little bit tedious. And there is a way you can do it on your calculator. If you enter this on your TI Inspire, if you enter this equation in the graph on a graphing page, and then go up to Tools and ask for it to show you a split screen table, it'll show you this whole table already filled out. That's something you might want to experiment with. Go to a graph page and enter this. Remember, it's gonna call this F1 when you do that. You're not required to do this or anything. And then you would just enter this general equation. And then you go to Tools and you look up, you know, a table. And it would spit out all these values for you. Okay? Just, Shannon. Can you plug this in, please? So I'm going to fill out the, you know, you can do this table on your own. And where is this thing? But all you're doing is sorry about the delay there. All these x values, you're just plugging it in to the equation and figuring out what y comes out to. And this is what this is going to look like if I plug all those in. Now, if I just give you a table like this, let's say I give you a table that's already filled out. You know, another way for you to determine the x-intercepts or the zeros is just by looking, where is the y value 0? Well, it's here and here. So you see, there's one of my solutions, and there's the other solution. Okay, so that's one way of doing it. I'm going to go ahead and sketch this graph out. -3, 0, -2, -3, -1, -4, 0, -3, 1, 0, 2, 5. Now, and then of course 3, 12 would be off the graph. But you know, notice how to get from here to here, we went up 1, 2, 3, 4, 5 over 1. So we could do the same thing here, up 1, 2, 3, 4, 5, the other direction 1. When you draw your parabola, you don't want to just connect the dots. You want to draw a nice, smooth curve. Okay? And, you know, you're not required to, but my axis of symmetry would be right down here going through the vertex. And of course, you also notice if I gave you a graph that the vertex would be this -1, -4, and you see how there's symmetry about this table, okay? You see how 0, -3, -4, and then it makes the turn, -3, 0, right? You see this is 2, 5. I hope you can predict that up here, if we were to show -4 for x, it would be 5 for y. And then -5 for x would be 12 for y, because it's going to match up with what's down below here. There's that symmetry going on. Okay? Okay. So on this next page, again, we're going to kind of tie this in together. Now, zeros of an equation, you can find them by factoring or using quadratic formula or using any of the solving techniques, square roots. Here, if we were to do that, this one's actually not that hard to factor. Both of these are prime, 2x and x. If I do 2 here and 1, you see I get 4x and x. I can make this work. So I know that my solutions are going to be 1/2 and -2 of that particular equation. Okay? Now, on a table, I'm going to give you some values here in a second. Remember, just the zeros, I mentioned this before, but that's the same as solutions or x-intercepts. It's all the same thing. So let's just, kind of write in what we had before, -4, -3, -2, -1, 0, 1, 2, 5, 0, -3, -4, -3, 0, and 5. Let's just say I gave you this table. Looking at this table, you would see, hey, there's a 0 in the y, so that's an x-intercept. There's another 0 in the y. There's another x-intercept. So my zeros, or my solutions, are -3 and +1. By the way, the word zeros, you'll see that spelled differently, and both methods are considered okay. Sometimes you'll see that second E after the O, between the O and the S, like it is here. Sometimes you won't. And then, of course, on a graph, it's very easy to spot the zeros. Sorry, I should have had this pre-printed, but with the graph on it. Here, let's just say that, let's go ahead and put a parabola on here. Well, boom, 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 boom. And then, of course, if that's one side, the other side's going to be exactly the same, symmetrical. And you're going to sketch that in. And of course, you notice that in a parabola like this, my zeros are, -5 and a -3. Okay, it's wherever that graph crosses the x-axis. We've been talking about that for a long time. All right. So here you have everything already given to you ahead of time, which is kind of really what I meant to do in the previous page too. But I would like you to find the zeros with all three. Stop this here for a moment and go ahead and give this a shot. But I'm going to talk about it here in just a sec. And we're going to be doing this together as a live lesson anyway. But number 4 should take you just a few seconds. Okay, we know that my zeros are there and there. So if I wrote it as coordinates, it would be -2, 0, and the other one would be 4 comma 0. Sorry, there should be a negative there. Again, a lot of times I don't write it as a coordinate. I'll just say the zeros are -2 and 4. But remember that they're 2 separate points, okay? 2 separate points. Okay, my document's not happy right now. Let's see if this is okay now going forward. Now here in the table, this is a different table. This table does not go with the graph in number 4. But if you were given a table, you look, hey, there are the zeros. And remember, when I say 0, I'm talking about where's the y value 0. Okay? So where's the y value 0? There it is. So my x-intercepts are x equals -1 and x equals +3. Now, some people look at this 0 and say, oh, what about this? Remember, that's something different. 0 comma -3, that's the y-intercept. Okay? That's something else. I hope you guys notice here that the vertex would be 1, -4. You see how it kind of bottoms out there? This one requires a little bit of work. I would try to factor, though. It does factor pretty easily. And you get zeros of 8 and 4. All right. So this is kind of hard for me to do. You're on this particular screen. It says match each quadratic function with its graph by finding the quadratic zeros. I'd like you to try to do this yourself if you're not going to the Zoom lesson. But take a look here. How I want to match this up is I want to solve these. I can't tell just by looking at those 4 graphs down below which one's which. Okay? What I can tell is I can find some solutions. I'm going to factor this. Actually, I'm going to factor all 3 of them. So what? This one becomes what? X plus 1, x plus 4. So I get solutions of -1 and -4. So look at down below. Where do you have a parabola that goes through -1 and -4? And I'm seeing B. You see how it goes through that. So you got to do a little bit of work here. I'm going to factor this one. Remember, just picture the y as a 0. This would be x and x. This would be 4 and 1. Make that minus, make that plus. It does work out. So I got 4 and -1. And that, of course, is going to be A. And then lastly, I can't just pick the last one because there's still a couple things to pick from. So I got x and x. I got 4 and 1 again. But this is plus, this is minus this time. I should have had a 0 in front there. And then I get x equals -4, x equals +1. And if you look down below, where do you have 4? What did it say? -4 and +1? And that's going to be C. So D we didn't use. All right. Now the ones on the back are the same idea. You just have a different thing to match on the back. Match each quadratic function with its graph by finding the quadratic zeros. Now, you might not be able to factor all these. Like this first one here, there's no factor pairs of 1 that are going to add or subtract to give you 1 here. So you're going to have to use quadratic formula here. So picture the y as a 0. A would be 1, B would be 1. Actually, C is 1 too. That's kind of cool. So opposite B plus or minus square root B squared minus 4 times A times C all over 2 times 1. Now check this out. I can stop here because I'm going to have 1 minus 4. I'm going to have the square root of -3. That means it is no solution. You can't take the square root of a negative. So look for the graph down below that doesn't cross the x-axis. And clearly there's only one of them, and that would be E. So yeah, you might have to do some work to do some of this matching stuff. Number 11, I'm going to try to factor that one. I have a little bit more room down here. See if we can. I think we can. If I use 2 and 2, yep, that works, doesn't it? So I get x. So I only get one answer. So which one of these only has one answer? And that solutions, and you see here, boom, that goes to the -2. And that was G. And I got one more to do. I see this. I'm taking out a GCF of x. I get answers of 0 and +2. That's a nice quick one. Where do we go through 0 and +2? It looks like H. So that is it for that lesson. Remember, the live Zoom lesson, this is on Monday, May 5th at 1:30. Okay. Believe that's correct. And we'll go over this in detail. You can ask questions then. Your homework is going to be in a worksheet for this particular lesson. See you later.